Hello there. We're going to talk about how to solve absolute value inequalities today. This is an extension of Chapter 3, and it's the last notes we'll be taking for Chapter 3 before our test. So, when we're solving absolute value inequalities, we can kind of separate these into two groups. The first group is absolute value inequalities that have less than or equal to. Those are kind of grouped together. So when we're solving these, the steps that we learned back in Chapter 2 apply. So if you'll remember in Chapter 2 when we did absolute values, we talked about how we had to isolate the absolute values. We had to get the absolute value all by itself. So if I was doing this first example, here's my absolute value. I want to get it by itself, so I'm going to subtract 2 from both sides. So then I have the absolute value of x is less than or equal to 4. So now I've got the absolute value by itself. Now the next thing that we did after we got the absolute value by itself was to set up two cases. Okay? Now without the absolute value symbol, okay, and when we were just doing equations, we would set up a case with a positive answer and a negative answer. We're going to do something similar to that here. So here's case 1. I get rid of the absolute value, and I just have x less than or equal to 4. Okay? Now in case 2, I'm going to change it to a negative 4 and flip my inequality sign. Okay? So case 1, x less than or equal to 4. Case 2, x greater than or equal to negative 4. So these are always going to be AND ones. The ones that have less than are AND. So if I write this again in order now, because negative 4 is smaller, I have x greater than or equal to negative 4 and x less than 4. Or if I write that as a compound inequality, it would look like this. Where x is between negative 4 and 4. So on my number line, let's put negative 4 on here, and 4. So x greater than or equal to negative 4, that's going to be a closed circle to the right. X less than or equal to 4, sorry, I forgot my line there. It's going to be a closed circle to the left. Therefore, they intersect in the middle. Okay? Let's do another one. So once again, I want to get the absolute value by itself. So I have absolute value of x. I need to add 5 to both sides. So I get absolute value of x less than 1. So again, it's time for my two cases. First case, I just have x less than 1. I just get rid of the absolute value symbols. Second case, I flip my inequality sign and make my answer negative. So I have x less than 1 and x greater than negative 1. Again, I'm going to write this so that the smaller number comes first. So x greater than negative 1 and x less than 1. If I write that as a compound inequality, it would look like this. So then on my graph, I'm going to put negative 1 on here and 1 on here. Greater than negative 1, so open circle to the right. Less than 1, so open circle to the left. And they intersect in the middle. Okay? One more example here. This one's a little bit tougher. So here, in my absolute value, I have x plus 4, and then minus 1.5. Now again, I want to get my absolute value by itself. So I got to get this x plus 4 by itself, so I got to add 1.5 to both sides. So I'm going to have absolute value of x plus 4 is less than, comes out to be 5. Now one of the most common mistakes here is to just subtract 4 out of that absolute value. I can't do that. Okay, I can't take anything out of the absolute value until I've set up my two cases. So first case here, I have x plus 4 less than 5. Second case here, x plus 4 greater than negative 5. I gotta flip my sign, make the answer negative. So now what I have to do is solve for x. So I'm going to subtract 4, subtract 4. So I have x less than 1. Subtract 4, subtract 4. X greater than negative 9. So again, if I write this in order, I'd have x greater than negative 9 and x less than 1, which would be the same as this compound inequality statement. So then if I put negative 9 on my number line and 1 on my number line, x greater than negative 9, so that's open circle to the right, x less than 1, open circle to the left. And again, they intersect in the middle, so I shade in the middle. Okay? So those are compound inequality, absolute value inequalities involving less than or equal to. Now let's look at the ones that involve greater than or equal to. It's going to be essentially the same process, but these ones are going to turn out as or compound inequalities instead of and compound inequalities. So again, I'm going to get the absolute value by itself. So I subtract 2, absolute value of x greater than 5. I've gotten the absolute value by itself. So I'm going to set up my two cases. X greater than 5. Second case would be x less than negative 5. So now I have x less than negative 5 or x greater than 5. So on my number line, I'm going to put negative 5 and 5 on there. Less than negative 5 would be open circle to the left. Greater than 5, open circle to the right. And that would be my graph for that one. Let's do another example. Absolute value of x minus 12 greater than or equal to negative 8. So again, I want the absolute value by itself. So I'm going to add 12. So I get absolute value of x greater than or equal to 4. So now I've gotten it by itself, and I want to set up my two cases. First case, x greater than or equal to 4, just like it is. Second case, x less than or equal to negative 4. So again, if I write them in order, x less than or equal to negative 4, or x greater than or equal to 4. Go grab my number line here. I'm going to put negative 4 on there. And 4. So x less than or equal to negative 4 would be a closed circle to the left. Greater than or equal to 4 would be a closed circle to the right. And one last example here. Again, this one's one of the little bit more complicated ones. I have x plus 3 in the absolute value. So I have to get the absolute value by itself. So I have x plus 3 greater than 14. And again, like I said, the most common mistake here would be to subtract 3. I can't do that yet until I've set up my two cases. So first case, x plus 3 greater than 14. Second case, x plus 3 less than negative 14. Flip the sign, make the answer negative. So then I gotta subtract 3. So I get x greater than 11. If I subtract 3 here, I get x less than negative 17. Again, this is an OR. So then on my graph, I'm going to put negative 17 down here because it's the smaller number. I'm going to put 11 up here. Less than negative 17, open circle to the left. Greater than 11, open circle to the right. And again, I would want to write this in order because it just makes more sense that way, where I put the smaller number first. Okay? So those are absolute value inequalities. Remember, they're kind of grouped by whether they're less than or greater than to start out with. We get the inequality or the absolute value by itself, and we set up two cases where the second one we flip the sign and change the answer to negative. Alright? If you have any questions, let me know tomorrow.